Welcome back to School of Civil Engineering. In this lecture, I'm just going to discuss with you that why we provide reinforcement in cantilever beam and in which way we provide reinforcement in cantilever beam. Actually, this is a important topic, and why and where we provide reinforcement in cantilever beam, I will discuss about that with you. So if you're new to our channel, then don't forget to subscribe to our channel and also press the bell icon, and also they have many video available in our YouTube channel. You can also watch that. That is all are required for civil engineering. So let's start. First of all, consider that this is a cantilever beam. Okay, this is a cantilever beam. So this is the cantilever portion, and here is a cantilever beam. Suppose this is a uniformly distributed load. So if we draw shear force diagram for it, so it will give a shear force diagram like from here. This is if we consider this is a 0 point, so it will go up. Then for that uniformly distributed load, it will come down, and here it will be 0. So we are seeing that at that point V, it's giving us shear 0 shear, and point A, it's giving us the maximum shear. Now if we go for moment diagram, so what will be the moment diagram actually? So here you are seeing that here it's giving us maximum moment and it's negative moment. Okay, so just after that we have to go like that way. Okay, we have to go like that way. So in my previous another video I have told you that where is negative moment, where is negative moment, okay, I mean where is negative moment, there is tension. What is negative moment? There is tension. So I mean for negative, if the negative moment, then tension is top. For when negative moment is, I mean here the negative moment are minus. Okay, I mean this is sorry, this is the negative moment, and for negative moment it's tension work in top, and for positive moment it's tension work in bottom. That's why for negative moment we provide reinforcement in top. So I will see it in details. So here is our beam and here is our moment diagram. Okay, so suppose consider that this is a column face, this is column face, and this is beam face. Actually this is column face and this is beam face. After that, here the column reinforcement, consider that this is the reinforcement of column, is the longitudinal and tie. After that, if I draw the reinforcement for that moment diagram, I mean for moment, so we have to provide reinforcement in top of that beam. Okay, because it will for cantilever portion, okay, for cantilever portion of our beam, the maximum tension will create in top. That's why we'll provide reinforcement in top, and also we will extend that reinforcement as a development bar. So here like that, and the question is, only will provide reinforcement in top? No, actually that's not. We'll also provide reinforcement in bottom, but we can provide the reinforcement actually they have no requirement of reinforcement in bottom. But if we don't provide any reinforcement in bottom, then its concrete bonding will be not good, and also here we can place stirrup for it. Okay, for that we'll also provide reinforcement in bottom, but it can be the smaller size than the top reinforcement. Okay, after that here just in this way, just we have to provide reinforcement. Now simply we'll provide stirrup like that in our beam. So actually the main thing is we provide reinforcement top. Okay, we focus on top for cantilever portion. Okay, for cantilever portion we focus on top because of its negative moment. Okay, its moment is negative, and that's why when moment is negative, the tension in top. Okay, so that is the way to find out that how we'll actually calculate the criteria and requirement for our reinforcement. So thank you very much, and thanks for watching. So if you're a civil engineer, then don't forget to subscribe to our channel School of Civil Engineering, and also press the bell icon, and also like our video, share our video, and don't forget to leave a comment, because your own comment inspires us for the next work. So thank you very much.